Welcome to Safety Chats. Host Jason Stark, Director of Safety at Baldwin Safety and Compliance, shares decades of aviation experience and a passion for safety. Let's get started with this week's Safety Chat.
Hello all, and welcome to the Baldwin Safety Podcast. And I am so happy you're here. Looking for topics, the current global climate is actually really good at creating situations and scenarios which could be hazardous. We've been seeing a large spike in fuel prices, not only for automotive, as you know, and getting fuel for the aircraft. When we look at fuel for the aircraft, obviously it's necessary, but we're very sensitive to the price. And I remember when we had the last fuel spike, I think we were seeing in some places jet fuel as high as $7, $7.50 a gallon. But at home base or at some other out-of-the-way airports that we'd go to, it'd be in the $5 or $6 range. And what that really led to, which is not a new practice, certainly wasn't then either, is the notion of fuel tankering. Fuel tankering, as defined, is a practice which, obviously when the aircraft carries more fuel than is required for flight. It's what you need plus your reserve plus extra. So why do we tanker fuel? Saving precious minutes on that turnaround time is key. And it may be, we got to take enough fuel to drop them off, get to our next airport, and have the reserve so our primaries or our passengers are happy so they're not sitting there or have to deplane while we fuel. And then, obviously, probably the biggest reason that we're seeing today, especially when fuel at home base can be on the order of a couple dollars cheaper than what you might find at a given FBO, especially in a heavy metropolitan area, is to save money. When we talk about saving money, it's interesting. Did a little research on that. Well, let me pause here for a second, because when we were doing this, we just kind of did back-of-the-envelope calculations. We didn't really have any heuristics or rules of thumb, if you will. We almost turned it into a game, and it was almost fun to say, if I take on an extra 400 or 500 pounds at whatever price here, what am I actually saving for the flight? It's funny, and in this article, doing some research on it, says, cost savings can be as small as just over $10. After all that work and scratching your head and just saving $10, then again, it could run into several hundreds of dollars. It just depends on the context. When we look in the airline, and I'm sure it's not too dissimilar for private and charter operators, but in the airline, the numbers that fuel accounts for about 17 to 25% of the total operating cost, which is pretty big. A quarter of your total operating costs are what you're putting in the tank. So obviously, if a quarter of your expenses are related to fuel and it goes up substantially, then obviously your overall operating expenses are going to go up quite substantially as well. So when it comes to fuel tankering, and again, looking at the airlines, because that's the numbers that were solid that I received in research, but airlines, when they fuel tanker, can save, roughly $290 million a year to this practice. And that's pretty substantial. And I think that is probably a pretty good impetus to engage in the practice. But as I said, the cost savings, it just depends on the context, but you could go through all this work and maybe save a nickel on the flight or save $10. But again, if done properly, you can save thousands, even millions of dollars in the case of the airline. Let's really look at the facts about fuel tankering. Obviously, tankering fuel means that you are carrying X amount more than what you need, again, to either reduce the turnaround time at your destination or more likely to reduce the total cost of fuel for that given trip. But when you carry more fuel, as you all well know, you burn more fuel. And it is interesting, I wish I had this a decade ago, but there is a rule of thumb when it comes to burn-off percentage. Typically, the burn-off percentage is 4%. So it's typically 4%, and that means for every 100 pounds of fuel carried, the aircraft will burn an extra 4 pounds, as an example. Put it into context, if we are carrying 1,000 pounds of fuel for a 2-hour flight, that means 8% in carried fuel, 80 pounds, because that's 4% an hour times 2. So when we're looking at, are we going to save money, the fuel at your arrival airport, depending on the length of the flight, in this case is a 2-hour flight, it must be less than 8% cheaper than the price of the payload to justify tankering the fuel. So it's a lot of mental gymnastics, especially if you're in the heat of battle, you're sitting on the ramp and trying to figure all this out. But it is a good rule of thumb. So 4% burn off for every 100 pounds of fuel extra that's carried. That's something to think about, but that's just the facts of fuel tankering, that you burn more fuel when you carry more fuel. Let's look at how that translates into some implications. And first, I want to start with environmental. Now, we had a podcast about a month ago dealing with sustainability in the aviation industry. And part of that is obviously environmental. The implications of fuel tankering in the environmental realm are pretty significant. And a lot of this research comes out of the EU because they're very conscientious, especially about carbon emissions. Some of the research has shown that a 300 nautical mile flight with fuel tankering can produce an additional 142 kilograms of CO2. While this doesn't seem like a lot, when you consider all the aircraft operating in the European airspace, that can add up to quite a bit. So as a matter of fact, the number that the EU comes out with is that fuel tankering could be responsible for an additional 901,000 tons of CO2. And this is not just CO2 emissions from normal operation of flight. This is additional CO2 emissions for fuel tankering. And when we talk about 901,000 tons of CO2, it's basically equivalent to the emissions produced by an entire city of around 100,000 people over a year. I mean, think about that. That is a lot of carbon emissions. So when we're tankering fuel, we're using more fuel, meaning that we're putting more greenhouse gases into the atmosphere, more carbon emissions into the atmosphere. So we have to be cognizant of that. And like I said, I'm sure, I haven't directly asked a bunch of flight departments, but I'm sure fuel tankering is happening because it's similar to the price increase and disparity when I was operating, that we're going to be doing a lot of fuel tankering, in some cases tankering a lot. So we have to think, what are we doing to the environment?
With Baldwin Virtual Training, you can take a safety course on your schedule from anywhere in the world. From frontline training to advanced training for safety managers can help you succeed in your workplace. Visit baldwinvirtualtraining.com to learn more. Now, back to Safety Chats with Jason Stark.
Well, for those of you that aren't really concerned about the environment, we get into the nuts and bolts of performance and aircraft. The fuel tankering, because you are carrying more weight, especially in the first leg, there's a lot more wear and tear on the engines. And a lot more wear and tear, for example, if you're landing at a heavier weight, on the brakes. And there's a lot more wear and tear on the airframe, a lot more stress on the airframe. So while we gave a really simple rule of thumb that the fuel at your destination, depending on the length of the flight, 4 hours or 4% per hour, it has to be that percentage greater. We're just taking cost of fuel, but we're not taking some of these indirect costs or these operating costs such as brake wear and tear, airframe stress, and engine wear and tear. So we don't think about that, but that is one of the implications of fuel tankering. Also, when we're tankering, we're heavy. Obviously, our climb rates, they're obviously reduced because we're heavier. We may not be able to get to an optimum cruising altitude at the higher temperature. So especially if the temperatures are higher, I should say. So we have a really big hit in performance. And not only in cruise climb, when we look at our departure gradients, while we may be able to make the standard departure gradient, if there are any special gradients that have to be complied with, that might be tough to do, especially with fuel tankering. Or sometimes we may be tempted to say, you know what, the cost of this fuel being cheaper, we're just going to gamble on the climb gradients, which is never a good attitude to have, but people get a little strange when it comes to money. And then obviously you're going to have longer takeoff distances, which is going to again be more wear and tear on the tires. You're going to spend longer time on the ground. You're going to be pushing the margins of the runway, and then same with landing distances. If you're tankering enough so that when you get to your destination that you're tankering for, if you're at or near maximum landing weight, you're putting more obviously stress on the airframe and then the tire and the gear and the brakes. Also, the airframe, like I said, you're landing at that heavier weight, and you're going to be taking more distance. Now, that comes into play specifically too if the runway is contaminated. But what I really kind of wanted to get into, though, are the safety implications. And I think safety implications are baked into the aircraft and performance implications that we just talked about. But when we talk about safety, when you're heavier, you in effect are limiting your options. Anywhere from the margin you would have if you should have a rejected takeoff, to climb gradient requirements if you should lose an engine, to even when you're at altitude and as high as you can get because of the extra fuel, and you need to possibly go higher for weather avoidance, you basically limited that option. So when it comes to tankering fuel, there are safety implications. Again, we talked about exceedance of aircraft limitations. It's very possible, especially if you don't have dumping capability and you have to come back and land for whatever reason right after takeoff. You're going to be well over landing weight, I'm guessing. And then, again, we can reduce safety margins due to the decreased performance that we're going to have. The climb performance, the at-altitude cruise performance, until we plane out. The increased weight itself is, again, going to reduce safety margins on everything because we're heavier and less performant. And then the one thing they don't think about with tankering is the other side. We've taken enough fuel to avoid paying the price of fuel at this one destination. So what we're saying then is we're basically going to take what we have left to our next stop, trying to do everything we can to avoid buying fuel at a premium at that one location. So when we do that, sometimes we may be pressing the limits on the other side. We may be going up against the door of not having enough fuel or cutting it really close because we didn't want to take on fuel because we said, hey, we tanker to avoid buying fuel. We would lose that benefit if we had to put more fuel on, so we're just going to blast off with what we have. And if you plan that it's enough, best laid plans sometimes don't always work out. And things like get-there-itis can start setting in and not really thinking about the implications of not having enough fuel. Some examples that we're giving is that you could be pushing the weather under VFR due to insufficient fuel to meet IFR requirements. You could be really kind of massaging the rules a little bit. You may be tempted to break IFR limits, especially on approach, due to insufficient fuel, especially if you don't think you have enough for your alternate because you really pushed it. So there's a lot of things, a lot of at-risk behavior that could start creeping in as a result of not wanting to take on that fuel and having what you have left so you don't incur that extra cost. So in terms of safety, there is a lot to think about when we're carrying that extra weight. It comes down to the question, should you tanker? And it's funny that one of the consultants I was reading about, he mentioned that the industry has a bias towards tankering, which is kind of odd, but his comment was that even if tankering isn't recommended, people still like to do it, even if it only saves $50, which is just kind of strange. I mean, I don't know if it's the game aspect of it, like even save a nickel, that it's kind of this idea of gaining something. I'm not sure, but tankering, especially when we look at that fuel is 17 to 25% of an airline's operating expenses, it can be beneficial. I'm not in this podcast saying that it's a bad thing. I'm just saying it does have implications, especially on the environment, the aircraft airframe, and the performance of the aircraft, and then safety in general. There are implications to fuel tankering that I believe an organization should address. As I said, it can be really beneficial, but it might behoove the organization to sit down and look at all the aspects of fuel tankering in context and the situations and say, okay, well, these are the controls we're going to put in place to avoid things like limiting options or wear and tear on the airframe. So that's something that, as part of your safety management system, is a great thing to do. Sit down, us as the safety managers, we can sit down with pilots and say, okay, we know this tankering is going on. Let's look at how it can go wrong and how can we implement controls to reduce the risk should something go wrong or should we have a challenge. And document it, of course. Again, we talked about the hazard log last week. You put it in your hazard log. Fuel tankering itself is a condition that has the potential to cause or contribute to an aircraft accident or incident. As a hazard, that situation, the fuel tankering, you can sit there and say, okay, what are all the things that could go wrong? Risk assess those things, and then implement mitigation as required. Not saying fuel tankering is a bad thing, but I'm saying it should be done smartly, and it should be addressed proactively rather than reactively, and have a policy about it, and then also, maybe have that 4% rule of thumb that I mentioned earlier, so that there can actually be empirical support for why you should or should not tanker. So that's it. I hope you learned a thing or two. I know in researching this, I did. As always, if there's anything you want to discuss on here, shoot me an email. I would love to hear from you. I look forward to seeing you all next time, and until then, stay safe.
This podcast is brought to you by Baldwin Safety and Compliance, the leader in safety management for the transportation industry. Since 2004, Baldwin has been providing state-of-the-art solutions and 24/7 support to the aviation and transportation industries. Baldwin's clients include all sizes and types of transportation operators. Baldwin provides safety and related business services to commercial and non-commercial transportation operators, medical transporters, FBOs, MROs, airports, flight schools, UAS operators, firefighters, OEMs, ground transport operators, and others. Visit BaldwinSMS.com to discover how Baldwin can enhance your organization's safety program.